Okay, guys, can you hear me?
Yep.
Okay, so first things first, I have graded the midterms. The grade should be on the D12. Now, since it was online, you won't have any feedback on each of your tests. So get in touch with me if you have any questions. But in general, let me show you this. So I have uploaded the solutions for the midterm. So this will help you get a sense of how the grading was done. I was trying to be as liberal as I could. So this gives you some sense of how I did the grading. The couple of students, I don't know if they're on this call or not, who got zeros and yet submitted something, but it was not the test questions. So if you took the test and you still got a 0, get in touch with me immediately. But in general, the class did well. Many of you scored full 30 points, so that's good. For the final exam, which as of now is scheduled for next Thursday, the standard would be very similar. Most of the examples that we have done in the lectures, during the lectures in the class, the test questions would be similar to those questions. But the final exam is going to be over 2 hours, so that spreads out the length of the exam. Okay, so let's start with today's content. What I first want to do is finish up what I wanted to cover in the last lecture. So in the last lecture, if you guys remember, we did a little bit of interpolation, and then after plotting these interpolation curves, which you would find in the video from the previous lecture, we also looked at how to get integrals. And we looked at, if we are given a function, how to get the integral over that function between certain limits, the corresponding Matlab command being quad. And so this is the example for that. So this gives the integral under that function, or in other words, if we can plot that function, it gives the area under the curve. So we did that example, and this is the other example that we did, where instead of a function being given to us, we are given a set of discrete points. The question is, find the area which is under the curve made by joining all those discrete points. And for that, we learned that the corresponding Matlab command should be traps when you have discrete XY coordinates. So make sure that you remember this. Number 1 is quad when you are trying to integrate a function. Number 2 is traps when you are trying to integrate or get the area under a curve, which is formed by joining discrete points. So this is, I think, where we basically left off in the last lecture. In calculus, the other thing that I wanted to cover is ordinary differential equation. And this is the generic format for ODEs. And you probably already have encountered this kind of differential equations in other courses. Essentially, this is the only structure that we are going to look at. There can be other kinds of differential equations. For this course, we are not going to worry about them much. This particular setup is called initial value problem, where you know the dy dt in the form of a function. So dy dt would be a function of both t and y, because it's trying to take the derivative of y with respect to t. So there can be both t and y. And then you will be given a certain range for that t. So let's consider t to be the time parameter here. So you'll be given a range for that time parameter. And the initial values would be given. So at t is equal to t naught, which t naught is the starting point of this range, you would know what is the value of y. And then you can numerically solve this differential equation using this parameter. So 3 points over here, you'd be given this function, you'd be given this range, and you would be given this initial value. So as long as you can detect these 3 sets of information, it is very easy to solve ODEs on Matlab. This is the syntax. So a number of ODE solvers, the ones that we are going to use are called ODE23 and ODE45. The numbers, if it is called ODE23 or ODE45, it depends on the numerical scheme that it is using. We don't have to worry about that. Even if it is ODE23 or 45, the syntax is going to be same. So you first grab the ODE function that's given to you that comes from this first information point. Then you grab the T span, which comes from this range that is given to you in the question. And then you get the initial Y value, which is given in this piece of the information. There will be an example like this in the test for sure. So make sure that you practice these examples a little. We are going to do one example today in the lecture, and make sure that you know how to separate out these three information points. Number one, function. Number two, the range of the T parameter. And number three, the initial Y value. And as long as you know that, you can just set up according to this syntax over here. So let's look at an example. This slide tells you the other ODE solvers that Matlab has. As I said, we don't have to worry much about all of them. The ones that we are going to use are either ODE23 or ODE45. I typically tend to prefer ODE45 because it just gives a little more accurate results. So with that background, let's try to solve this example. We are trying to solve this ODE. dy dt is this function. So as I said, the function can be dependent on both t and y when it is a dy dt. And the range of t is given to you, and the initial values are given. So as long as this is fine, you know the three pieces of information. The rest is relatively easy. So let's just look at the example that we have over here. And let's actually write a code instead of doing it on the command window. So we are solving for this ODE. So clear all, close all, and CLC. The first thing that we need to do is to figure out the function, because the function goes in the first part of the syntax. And the way it is going to be handled is through the use of anonymous function that we learned earlier during the course. So let that function be func, for example. And I said that this function, the dependent parameters are both t and y, because both are there in that function. So ty, and then t over here, we are trying to solve for the yt sets over a certain range. So we need to use the dot parameter as well. So a dot, and another dot before the division operator. Okay. By the way, my internet just dropped out a little. Can you guys hear me?
Yep.
Okay. So the function has been set up. The next thing is just writing out the syntax for the ODE. In ordinary differential equations, you'll solve for both the parameters. So I'm going to write it like this, because both t and y are supposed to be solved for, because that's how you get the information over how that ODE is behaving. So both t and y is being solved. We are going to use the Ode45 solver. Then the first part of the syntax is the function that you have already set up. So that is called func over here. The second part is the range of t, which is given to you over here. So 1.0.1 to 3 is the range of t. And then the initial value for y is 4.2 at t is equal to 1. Make sure that this initial value of t and the initial point of t, they match out. They should match out. If they don't, then you need to think a little on that. Or if that happens during the test, you need to ask me a question. So this t value over here and the initial point of the t over the range should match out. So at t is equal to 1, which is the initial point in this data set, y is 4.2. So just plug in that into the syntax. So that sets up the solution for the Ode45. One key thing, this is a round bracket, not a square bracket. And finally, we are supposed to plot this because typically when we solve ODEs, uh, it will not really make much sense if you just looked at the discrete solved data points. You want to plot the function to see how it behaves. So plot t comma y. So let's save this. So this is select 11 code 1 fall 2020. So if I now run this, see this is what I get. Now you can make this curve smoother by going for smaller increments on t, because basically what it is doing is solving that ODE at each of those discrete t points. So if you go for a smaller delta t, this curve just would get a bit smoother than what it is already. So for example, like the version that I have over here, initially I had just used a 0.5 increment for t, and you can see that it's not at all a very smooth curve. Any question on this one? So do expect an example, a question like this on the test, and make sure that you know how to solve this. Few points again, you need to know the function, you need to know the range, and you need to know the initial value for y. And once you know those things, the first thing that you would do is to set up an anonymous function. And that way it is slightly different than what you might expect. But this is how the ODE solvers work. They can only work on the anonymous function handlebars. Okay, any question on this one? Okay, so far so good. So this was an important thing that you need to practice a little before you take the test. One more thing that I've shown over here, which is kind of related to this, is what happens if you have a number of initial values. So over here, the initial value was just 4.2. But what if we have a number of initial values? How do I tackle that? So let's try to edit this code. So for I equals 0 to say 40. And if I put that I here instead of the initial value of y as per the previous example, let's see what happens. So what would happen is in each run of the loop, it would pick the current value of I as the initial value for which this ODE is supposed to be solved, and it would solve it. Now let's plot each of those solutions. And to get those plots, we need to have the plot command within the loop. Otherwise, if we just run the entire loop and come out of the loop to get the plot done, then it would just show the final value. So let's plot them at each of the run. And to make sure that all the plots show up on the plane from the multiple runs, we need to have the hold on command. It is conceptually similar to what we did before, where we used hold on to make different plots appear from different parts of the code on the same plane. So let's see what happens now. I wanted to do this because it looks so pretty, and actually you already can see the screenshot, but still let's look at this. So this is code 2. And it might take a little longer to run because now it is trying to solve all the different sets of ODEs from the multiple runs. But anyways, it's done here. So you can see that all these different curves, they correspond to each of the individual runs of that for loop for different sets of initial values. And the initial values, they come from 0 to 40. So this y-axis, the values starting from there are the initial values of y. And based on the ODE, based on the function, the y would vary over time like this. So what the final solution looks like is very much dependent on what the initial value of y is. And conceptually speaking, that might not be a very important thing to learn in this course, but this is very important as you develop yourself as engineers, it's very important to know what are the initial conditions, what are the boundary conditions for any mathematical scheme. And then only your code would give an answer that is correct. Any question on this one? Okay, so make sure that you know how to solve these examples, both this one and the one before. Okay, so a few quick things that we are going to learn today is how to solve equations on Matlab. And I don't know if you guys remember in the very first lecture, I said that Matlab is not very good with symbolic manipulation. You have other programming languages for that, but Matlab can still do simple stuff, and it can definitely solve simple algebraic equations. So that's what we are going to learn over the next few minutes. So let's try to wrap this up over the next 10-15 minutes, because it's not that critical, but you might expect small 2-pointers on the final exam from this part of the syllabus. So what essentially we are trying to do is, we have an equation. It can be an equation on just x, it can be an equation on x, y, z, certain number of variables, and we are going to algebraically solve for x or y from that equation. So let's try to write a code for this. So again, clear all, close all, CLC. And this is called symbolic. Basically, we refer to it in the programming world as symbolics, where we are just dealing with symbols and we are no longer concerned about the numbers. And that's why this is not really MATLAB's playing field, because as I have been telling you, MATLAB always tries to think in terms of arrays and numbers. Over here, it is just a special toolbox that MATLAB has built over the years to make sure that you can also solve simple algebraic equations. But since we are not dealing with numbers anymore, you need to tell MATLAB that we are not dealing with numbers anymore. So stop thinking about numbers. So we do that by this command. So sims a, b, x, y, z. So whatever parameters might appear in the equations that you are trying to solve, you write them over here. And this command sims tells MATLAB that it does not need to think about numbers anymore. The commands that are going to follow are purely based on algebraic equations. Okay, so let's see how this works. So suppose we are trying to solve an equation, say 10 times x minus 20 is 0. Let's imagine that we are trying to solve this. We all know it's very easy, x would be 2. So let's see if MATLAB can do this. So solve 10x minus 20, and let that be assigned to this thing called answer. Okay, so let's save this. If I run this, so it has solved it. But you see that even to solve this very simple equation, it took like what, 4 seconds? So that tells you MATLAB is not the best candidate to solve very complex algebraic equations. I personally prefer a different scientific computational language called Mathematica. Some of you would learn this later on in your careers. But know that there are some other alternatives out there when you are dealing with purely algebraic equations, and MATLAB might not be the best tool to use, but still, as you grow more conversant with MATLAB, if the equation is simple enough, you can just stick to this. Okay, so it has run this code. So if I now just type answer, it gives you the answer, which is 2 over here. So this is the main thing that I wanted to show you guys in terms of the symbolics. You have a command called solve, which can solve for unknowns. Now, MATLAB typically, if it sees any kind of algebraic equation, there is a pecking order. So suppose if I write something like this. So basically, we are trying to solve an equation which is 10x times y, 10x minus 20y equal to 0. So suppose this is the equation that we are trying to solve. Now MATLAB has a pecking order in terms of which variable it is going to solve for. This equation has two variables, x and y. We know that we cannot solve for two unknowns from one single equation. But still you can try to express x in terms of y, right? So you can take this to the other side and you divide by 10. So x is basically 2y for this equation to hold true. Now for MATLAB, it would just solve for x unless you tell it otherwise. So let's see what I mean by this. So if I stick to this version of the code and let's save this as code 4. Let's take the semicolon out because then it directly would give us the output. Save this again and then run it. So see, now if you didn't tell MATLAB anything special, it just gives x. So 20 over y, 20 times y divided by 10, so 2y. But suppose x is not the variable that you want. You want y instead. So what you do is you add this y, the variable that you are trying to solve for, after the main equation. So if I again save this as, code 4, and if I try to run this again, so now the expectation is MATLAB is going to solve for y. So it would give the answer as, so the equation that we have is this. So if it tries to solve for y, it would take 20y to the other side. So basically it would be x over 2, right? So that's what we should get. So let's see if that is what we are getting. See, x over 2. So if you are trying to solve for anything else except x, you need to tell MATLAB that that is the variable that it would want to solve for. Similarly, if it has other variables like a, b, etc., you need to tell that over here. So I think that's basically what I have been showing. This particular thing says that if the other side and make it equal to 0, and then you don't need to use this double equal signs. So make sure that you go through all the screenshots. And this is where I say that if you have an equation where there are more terms than x, and if you are trying to solve for something else apart from x, you need to tell MATLAB that this is what you are trying to solve for. And for this screenshot over here, I've already initiated what is u. So u is the equation. So I have separately told MATLAB that this is the equation that we are solving. And then in this next line, I just solve for x. And then in the third line, I solve the equation so that we find a in terms of the other algebraic symbols. Any question on this part? Of course, by the nature of this content, you won't be able to write a long code on this. So what I'm going to possibly ask you is be prepared to have small 1-pointer, 2-pointer questions on the final exam, where I might ask you to solve simple equations using this symbolic tool. And the most important thing over here is to start, even if you're working on the command window, of course on the editor window, when you are telling MATLAB that you just need to think about symbols, you need to include this line, sims, ab, or whatever parameters are there in that equation. And then you use the solve command. Unless you tell MATLAB that this is the symbolic world, it won't give you any answer. It would give you an error that I don't know what is x or what is y, just like the errors that we have been getting all this while. Like if you have a parameter in any of the computations on your code, but you haven't told MATLAB what the initial values are, it gives us an error, right? So you'll get an error if you don't have this line in this kind of examples. Okay, any question on this one? Okay, so the next thing that I wanted to do is still stay in the symbolic world, we are still not dealing with numbers, but how to take derivatives in the symbolic world. So for example, suppose we want to take derivative of x squared plus 1, okay? So we know that if we take a derivative, first derivative of x, for example, it is just what, 2x? So let's see how we get that. So the command for that is diff x squared, and you are taking a derivative with respect to x, and you need to tell Matlab that. And if it is just the first derivative that you are taking, you need to tell that order as well. So the first derivative would stand for 1. But this is not all. You are still in the symbolic world, right? So what I said is the first step, even if you are working in the command window, is to tell Matlab that this is the symbolic world. So sims x sets Matlab up for tackling just symbolic algebraic equations. And the next step is you are trying to get that derivative. So this is the syntax. You first plug in the function, then you plug in x, which is the term with respect to which you are taking the derivative of that function. And then you type in the order of the derivative, if it's the first derivative or if it's the second derivative. So let's see what we get from this one. We should get 2x because ddx of x squared plus 1 is just 2x. So indeed we get 2x. On the other hand, if we take a second derivative of 2 of this function, can you tell me what should be the expected output? Anyone? Yeah, someone wrote, yeah, Justin. So just 2. So hopefully that should be the output. So indeed that is. So if you get something else, make sure to double check your work. Okay. So similarly, if I now take the third derivative, it would be a 0 because you cannot take a derivative of a number. So that is 0. So Matlab would be able to do this kind of computations. And as long as the equations are not that complicated, it should be fine. The next thing that I want to do is how to get integrals. And again, we are still working with just symbols. So let's look at this particular example. Here I have the function that is supposed to be integrated as sine y minus 5y squared. So you plug in that in this. So this is the function. This is the variable over which the integration is being done. So actually here the only variable is y. So we are going to integrate that function of y over dy. So you put in y over here and then the two limits a and b. So let's look at an example. So let's type out the same function. So we are working with x squared plus 1. Let's imagine that we are integrating it over from 0 to 2. So 0, 2. But before all this, we need to again tell Matlab that we are in the symbolic world. Then let the integral be this. So int bracket. Let's now look at the syntax. So first goes the function. So the function is here. The next thing is the variable, which is the dx or the dy term over which you are doing the integration. Over here, we just have dx. So x. And then the two limits. So let's do a quick calculation of what the answer is going to be. So integral of x squared plus 1 dx. How much is that? So if I have a pen and paper, I can do a quick integration and you guys can work on that as well. So we are trying to do x squared plus 1 dx, right? So we have x squared dx plus integral of dx. So x cubed over 3 plus x 2, 0, 2, 0, 8, 3 plus 2. So the number that I'm getting is 14 over 3. So which is 14 divided by 3 is 4.67. So let's see if I am right, or if I'm wrong, then of course I need to double check my work. And if I still feel like I'm correct, then I need to double check Matlab's work. So let's run this. Indeed, 14 over 3. So if you're quick with your calculus, you can double check your work all the time. But typically, why do we need computations? We don't need computations for things that we can do by hand, like the one that I just did, right? We don't. I don't need computation to get this thing done, and many of you won't need any kind of computing support for this. So basically, when we would find this useful is when the equations, the functions are much more complex. So you need to play around with Matlab and see if it serves your purpose when you come to this kind of work. And if it doesn't, you need to probably learn other scientific programming languages. But philosophically, most languages work in same kind of algorithmic development, logic development process. So the experience that you guys are having through this course should help you while learning other tools as well. Any question on this one? Okay, so I would come back to this. So I want to discuss a few things about our final exam. But before that, let me show you a few other things, which probably is not going to be that important for the final exam. And in a moment, you would know why. But we are going to come back to this. So let's, I need to move to my other computer. So let's stop screen sharing on this one and let's try to open it through the other computer. Okay, so before that, the thing that we would do is something called sound processing. So Matlab can actually play around with audio files. And I would upload this particular lecture on D2L. What you would see is the main, the main Matlab command is audio read. Audio read is something which helps Matlab to import an audio file into its memory. And once you do that, you can play it slowly, a particular audio file. You can play it really fast. If you have multiple audio files, you can mix them up as well. Sorry. So yeah, this is the audio read function that I was talking about, which is used to in Matlab to import an audio file into MATLAB's memory, and then it can play it at different rates. So the way you play it at different rates is through a command called sound. And this second number here is actually a quantifier of how fast Matlab is going to play that audio file. You can mix them up as well by just, so here S1 is storing this particular file, S2 is storing this particular file. You can mix them up as well, just as S1 over plus S2. But what are these numbers for? So for example, if you look over here, if you're trying to grab, say, the music from the 5th second mark to the 8th second mark, this is the syntax that you are going to use. And this number depends on the sampling rate of the audio files. As I said, Matlab almost always, except it is doing symbolics, it deals with numbers. So even with audio files, it would try to generate frequencies and amplitudes based on the audio file and store them in the form of arrays. And then you need to tell them which particular frequencies you want to play. So the main things for this part is you know how to import audio files and you know how to mix them up. Of course, the screenshots will be there on the lecture. I'm going to play a few audio files in a moment through my other computer. And before we go into that, there is a command called imread as well. This is to import some image files into MATLAB. Again, this is not going to be important for the final exam, but as you use MATLAB in your other engineering coursework, you would find this useful, how to import different images, different graphics into MATLAB. And this is a fun picture. This is actually in the Crosses Hall in 1966. And this is in 2018. So there was a tree which got taken off. Some new things were added to the building wall. But basically, I have tried to include, like import these images into Matlab, and this is the screenshot for that. So just play around with this. But even if you don't have time to work on these things, save these lecture notes, and later on when you actually use Matlab for any of your coursework, or if you're doing any research, you can come back here to figure out how to read graphics files into Matlab. But for fun, let's look at how to play around with audio files. And for this, I'm going to start the other computer. I don't know if you'll be able to listen. This is very easy to do in the classroom, but let's see if you can actually listen to the audio files. So let me stop the screen share from this computer, and let me open it on the other one. Can you guys see the other screen? Hey, can you see the other screen? Yeah. Okay. So what we have here are 3 audio files, and actually, if you go to your D2L, there is a new folder called Matlab Music, where I have uploaded all these 3 files, so you can use them whenever you want. Okay, so this, as I said, is the command to import the first audio file, the second audio file, the third audio file. So the first one is the bass, the second one is the drums music, the third one is back. And here you can combine the files together, and these lines are to play them. So let's first try to play them individually. So let's comment that line out, and let's first try to play the back. So let's uncomment this and save this and run this. Could you guys hear any music?
Yep.
Yeah.
Okay. So this is, and as I said, this particular number stands in for the sampling, for how fast the music is supposed to be played, and that is related to the sampling rate. So let's change this. So let's change it to say 5,000, and let's run this again. Actually, this is too slow, so let's do 10,000. On the other hand, if I just change it to a very high number, say 50,000. So this sounds more like Bach, right? Okay, so let's stop this one and let's see what happens if I can combine 2 files together. So for that, you figure out the range of the music file which you are trying to add. They should match up. It's just similar to any code that we have written before, where the different arrays that you are trying to add, their order should match up. So here from S1, which is the bass file, I am grabbing 5th second to 32nd. And from the drums file, I'm grabbing again 5th to 38th second. If you don't do that, then you get an error. Okay, so let's combine this, but this is not going to play everything. The play of the music happens through here. So let's run this. give you a certain sense of how the mixture looks like, let's comment this line and let's just listen to the line on the drums. Sorry. So this is the drums, and you can play around with this by changing the rate at which it is played, but you can also mix it out with different music. So for example, I think it would be fun to mix drums with the Bach. Let's do that. So this is Bach. Let's try to play that. Okay, so there is an error. So okay, the S back is probably, it doesn't have enough notes in it to play it. But you get a sense of how things that you can do on Matlab with just audio files. So if any of you, if you guys are interested with audio mixing, Matlab is the tool that you'd probably start off using before you go into other softwares. So let's stop the screen share from this computer and let's shift back to the other one. Are you guys with me? Can you hear me?
Yep.
So I think there was a question on the chat window. If the final exam is on October 8th, what comes after that? Is that the end of the class? No, it is not the end of the class, and I'll come to it in a moment. Okay, so what we did in this class until now is just MATLAB, but the syllabus for ME 212 is not only MATLAB. MATLAB is essentially half of it, or you can at most consider it to be 60 or 65% of the entire syllabus. The remaining parts are SolidWorks and Excel. So this is a course that is, I guess you guys know by now, but it is co-instructed by me and John Verstick. So John is going to take over after we are done. So we have the final exam, as you note, on October 8th. From the following week, John is supposed to take over, and he's going to, I think he first would start with SolidWorks, and then he'd go into Excel. SolidWorks is how you develop different engineering designs. So it's just a different flavor, different kind of work. It's not programming. It's more engineering design. So yeah, no, the things don't end with this with MATLAB. You probably won't see me in a while after that. I do plan to come back at least for one session at the end of the before the classes end, because I want to collect your teaching evaluations and I want to do it live. But we are done with MATLAB by next week. And once you take the final exam, you don't need to worry about MATLAB anymore, at least for the next couple of months. Okay, so let's look at the syllabus, the exam. The structure is going to be, well, the logistics are going to be similar to midterm. So I'm going to send out the exam booklet 10 minutes before the actual time starts. We are going to be live on Zoom, so you can ask me questions. And you need to keep your videos on, of course. You can use one formula page, which I had allowed in the midterm as well, and I had told you to use just one side of it, but now you can use the other side. So you have two sides of one page to jot down whatever you want to write, but you are basically going to use your own computer. So technically you should have access to all the codes that we wrote during the live lectures. The calculator, useful, and it's a 2-hour exam. Now, over there, I have a question for you guys. We cannot have a 2-hour exam at 11 a.m. because many of you have other classes after this lecture. 7 to 9 p.m. I'm pretty certain that you won't have anything in terms of classwork at that time. Would this work for you guys? Okay, someone said yes, but if it is a no for anyone, uh, please email me immediately, even if you are not here and if you listen to the lecture later on. Oh, someone said you have calc at 8. Okay. 6 to 8, is that better? Because if it is just for 1 or 2 students, I can arrange to have it at a different time, which might work with that person's schedule. But it would be difficult if there are too many overlaps. So Ryan, you said that you have calculus at 8. Would it work if it is 6 to 8? Okay. Oh yeah, so your calculus is at 8 a.m. I'm talking about PM here. So it's in the evening. So I don't want to grab any of the time during the day. Okay, so let's stick to 7 to 9, because if we do it during the day, there would be other classes and it would be a mess. And I know some of you would have work at that time. If you cannot figure it out, let me know and then I can try to arrange an alternate slot for you. But try to figure it out. It would be easier on my part. Okay, so it would be October 8th, 7 to 9 p.m. on Zoom, and I'm going to send out the exam booklet before the test. Now for the final exam hints. So this slide should help you figure out which parts of the syllabus you want to focus on. Again, go back to the lectures that we had on functions, the user-defined functions, the anonymous functions. Practice them again. Practice out the scripts that we wrote. Basically, starting from the lecture where we started to write codes, the script files, the function files, practice them as much as you can. Then we generated random arrays for numbers of say 50 random numbers between say 0 to 10 or 0 to 100. We did those kind of problems. Make sure that you know how to do those things. We also did an example on, once we have a random set of numbers, how to club them up. So how many of them are between say 0 to 25? How many of them are between 26 to 50? We had an example on that. So practice those kind of problems. Now the polynomial curve fitting, the plotting syntaxes. So we have done a lot of polynomial curve fitting in the last 2 lectures. Make sure you don't have any big doubts from those things. Essentially, as long as you can solve everything that I had covered in the lectures, you are good to go. Small 2-pointer questions, 1-pointer questions for the symbolics. As you can sense by now, the focus is going to be more on the content that we have done after the midterm. So make sure that you cover these last few lectures as well. So, and that includes the symbolics that we did today, and also the ODEs that we did today. The polynomials, the different commands that we learned for calculus and polynomials, like polyfit, polyval, roots. There are a number of commands that we have covered over the last 2 lectures. And I would have an example on series sums again, because that is an important concept. Many of you did not get it right in the midterm. We have done a couple of examples in the lectures, so make sure that you know how to solve them. So this is the overall structure of the final exam. There will be 8 questions and all particular parts of the syllabus. Now, some of you had, do you have any questions on this one? I want to use at least a couple of minutes to give you some hints on the homework problems. So stick around if you can. So this is the final exam. Now, in terms of the homework, some people have questions on the last homework. So basically, you need to take a log of the given p-values, and that would put the equation that you are trying to solve for in the format that we have learned in class, in the polynomial format. So this might help you get a how to go about it, but email me if you have more follow-up questions. The other one that I wanted to cover is this one, where have to plot a function over a certain range of x and y. And actually you need 3 for loops. So the 2 outer loops for the x and y range, and then you are doing a series sum here, right? So you need another small for loop inside to get the series sum. So hopefully this would give you some hints on how to go about that homework. Okay, and only a few of you are left here. So Zach is going to have a help session on Friday, and it is going to be from 7 to 8, and I'm going to send out an email on that. Okay. Try to be at the help session, but he's also going to record it on Zoom. And 7 to 8 is the time on Friday. So it's this Friday. So basically tomorrow. So I'd let Zach know, and he would send out a Zoom link before the help session. Any questions?
I do have a question actually. So like in the Dropbox on D2L, it says like the Matlab certificate. Where do we find that to access that?
Yeah. So you mean how to get to? So basically, you are going to submit the certificate over here at this Dropbox link. I think your question is how to get to that Matlab on-ramp course, is it?
Yeah, where to get to that?
Okay. I think I have it on one of the lectures. Let me just find it out. I don't have it right now. So let's just figure it out. So was it lecture 8?
I believe it was 7.
7. Yeah. So basically, if you use this link, yeah, and so you should come over here and then launch Matlab on-ramp, and then follow. So the slides on lecture 7, they have some screenshots which would help you guide, but this is the link that you are going to use.
All right, thank you.
And I think some people have already submitted their work, so it should not be difficult to at least access the course. Any other questions? Okay, so technically this is the last Matlab lecture. We don't have a class on Tuesday. Use that time for studying for the final exam. But if you have any questions, email me. We can also set up a time as well. And I hope to again visit you guys back before the semester ends. Apart from, of course, we are going to see each other on the final day, which is next Thursday. But I want to also have a small session at the very end. Anyways, any questions for me? Okay, so see you guys on Thursday. Don't forget the help session from Zach tomorrow at 7 to 8.